Okay, we're going to start with section 14.4 it's primarily dealing with adding fractions, in particular rational expressions. So remember, when we add fractions, we always find the LCD of the denominators. So let me add just a little bit of reminder. So let's look at the LCD of A, B, and we can just think of A and B being whole numbers right now. Now, if just say one of the two, so I'm just going to arbitrarily say one of them, A, divides B evenly. For example, the LCD of 4 and 20. Here, 20 divided by 4 is equal to 5. That's what I mean divides evenly. It has no remainder. Then the LCD is the 1, which is evenly divisible by the other. So the LCD of 4 and 20 is equal to 20 because 20 is evenly divisible by 4. So let's extend this to, say, a polynomial or a polynomial term. What about z squared and z to the 5th? Well, z to the 5th is evenly divisible by z squared because that's equal to z to the 3rd. So if you notice the rule here, we take the one with the higher power. And one last little reminder, there's a lot of theorems on LCDs, but we're going to be using this one, and this is its expression when we're looking at variable terms. And then we have another one, the LCD of A and B, when A and B share no common factor. That's equal to just the product, A times B. For example, the LCD of 3 and 5. 3 and 5 are both prime, so they don't share any common factors, so that's equal to 15. The LCD of 2 and 5, again, they don't share any common factors. That is 10, which is 2 times 5. The LCD of 6 and let me think of one, 15 is equal to 6 times 15. Why? No, that's not. Sorry, I chose the wrong one. 15 shares a factor with 6, doesn't it? 15 and 6 both share a factor of 3. So that's not the one I want to do. Let's do 6 and 25. That will work. Well, they share no common factors, so that's equal to 6 times 25. So these two properties here, how to compute the LCD when the two operations don't share any common factors, and when they do, are going to be used. And I'll give you an example of this down here. The LCD, and we're not going to be using it so much, of x and x plus 3. Neither of those, actually both of those are prime, would be equal to x times x plus 3. So that's the example of this second case when we're talking about polynomials. I probably made it seem a little bit more difficult than it's actually going to be. But I think we're going to be using these properties again and again. So let's add x over 9 plus 8 over 7. So the first thing we always have to do is find the LCD of 9 and 7. And notice I can immediately use my property. 9 and 7 don't share any common factors. So the LCD is just their product, and 9 times 7 is 63. Now I'm going to do this two ways. You all have been used to adding fractions vertically. And you can continue doing that for the rest of your life. At some point, you get used to doing this enough so that you don't have to rewrite them as stacked. But let's do it. 63 divided by 7 is 9. 9 times 8 is 72. 63 divided by 9 is 7, and 7 times x is 7x. So this is the same thing. I can now add them. I have a common denominator. So when I add them, I look at the common denominator, which is 63, and then I just add the numerators. Here's one numerator. That's 7x. And here's the other numerator, and that's 72. And I can't factor, in this case, 7 and 72 don't share any common factors. So that's it right there. This is a really important task. The better you learn how to do this, the better you'll be prepared, because when you get to intermediate algebra, most of everything you're going to be doing in there, until you get around chapter 6 or so, when we get to rational expressions, you've already done. And they're just doing it a little bit more, and everyone has a hard time with rational expressions, especially in adding them. So learning this right here, or keeping it on hand to review, will be a good method to not freak out when you get to that section in intermediate algebra. Again, 5 and 11 do not share any common factors. So the LCD is 55. So let's do this. X fifths minus 3/11. And if you want to write that as x fifths plus a negative 3/11, that's fine. But our point is to find what those fractions are equal to when we look at them with a common denominator, least common denominator of 55. Well, 55 divided by 11 is 5, and 5 times minus 3 is minus 15. 55 divided by 5 is 11, and 11 times x is 11x. So my answer is my common denominator, so the bottom's always going to be your LCD value, and then I just take the numerators and I add them. 11x minus 15. Remember, 11x minus 15 is the same thing as 11x minus 15. All over 55, because there's nothing I can do to simplify the numerator. Actually, when I teach this class, I actually have a formula and just a procedure. I mean, it's so difficult for students that I just give them this whole method to do it, and tell anyone who knows another way to go right ahead and use the other way. But most students haven't the slightest idea of how to do this. So we have to find the LCD of 40 and 5x. Well, that's going to be equal to the LCD of 40 and 5 times the LCD of x, so times x. Because x is not found in both factors, literally what I'm doing here, if you really want to see, and I should show you that. I just gave you a formula. going to be times the LCD of 1 and x. So if you want to write 1 as x to the 0th and x, you can do it this way. So what you do is you split the constant terms up and then the variable terms. And here, remember, our rule was to take the variable term with the largest power. So that's just going to be x. And the LCD of 40 and 5, well, 5 divides 40, so that's going to be 40x. So that's not so bad. So this is a 2 right here in case it doesn't look good. So I know what the LCD is. It's equal to 40x. So here's what you do. If you have a variable term, if the variable term appears in all of the numbers or the expressions whose LCD you want to find, then take the term with the largest power. If it doesn't, you always just look at the variable terms and take the term with the largest power, even if they don't appear in others, because you can always write the LCD of 1 of an x is the LCD of x to the 0 of x. So in other words, I could have written this LCD of 40 times x to the 0 times 5 to the x, and that's going to be the same thing as the LCD of 40 and 5 times the LCD of x to the 0th. Remember, that's 1 times x, and there I get 40 times x. At any rate, let's go ahead and add these. We're going to pretty much stick to really baby examples for this particular last lecture for this week. So I have minus 9 over 40 minus 2 over 5x. So I'll write it over my LCD. So 40x divided by 5x is 8. And 8 times minus 2 is minus 16. 40x divided by 40 is x. And x times minus 9 is minus 9x. So now all I do is I write the LCD on the denominator and minus 9x minus 16, just the sum of those two on the denominator, and we're good to go. Okay, so let's do the next one. Whoops, scrolled the wrong thing. So this is 1D. So we want to add 6. And if you all know different ways to do this, and you're getting the right answer, you continue on. So again, we're going to use now what we just did, the LCD of z and z squared. What do? Well, z divides z squared, so we choose the one with the larger exponent. So we rewrite these. There will be no change in that one. Well, clearly that has to be 6, right? Because they're equal to each other. So z squared divided by z is z, and z times minus 4 is minus 4z. So the answer is 6 minus 4z. I'm just adding the numerators over z squared. This one, however, is different. We can actually simplify the numerator here because we can factor out the GCD. And the GCD of these two terms, the GCF of these two terms, is 2. 6 divided by 2 is 3, and 4z divided by 2 is 2z over z squared. And this is the preferred answer. I mean, this one's correct, but this one's more simplified. Because think about it, if the bottom turned out to be 2z squared, then we would have a factor that we could cancel out. But of course it didn't turn out to be that way, so it didn't matter. And these will be our last two examples. This is going to be a really short lecture. Let me do it back to yellow. So 5 over r plus 9 over r minus 3. So we have to find the LCD of r, and you need to write r minus 3 as a factor. Now both of these are prime. I can't factor out anything out of the r, nor can I factor anything out of the r minus 3. So the LCD is r, their product, r minus 3. They don't share any common factors. And here is the important part. Let me put it maybe in green. Leave the LCD in its factored form, always. Well, if my math lab wants you to do something different, you have to do what it wants, but it's always better to leave it in the factored form. Why? Because sometimes you actually have to factor them, and there's some work. Here it was really easy. And once you do all that work to factor something, why undo it? So I have to do 5 over r plus 9 over r minus 3. Well, this is my LCD is r times r minus 3. And my LCD is r times r minus 3. So r times r minus 3 divided by r minus 3. And if you want to put those in parentheses so you realize it's a factor, that's fine, is r. So r times r minus 3 divided by r minus 3 is r. And r times 9 is 9r. r times r minus 3 divided by r is r minus 3. So this is 5 times r minus 3. So the answer is, here I have my LCD, r times r minus 3 is equal to 5 times r minus 3 plus 9r. So notice that I say leave the LCD in its factored form, and let me add to that, as denominator. But the numerator you need to go ahead and simplify. So I'm leaving my denominator exactly as it is. But I've got to multiply out my numerator. That's 5. So use distribution. It's not hard. That's 5 times r. That's 5r. 5 times minus 3 is minus 15 plus 9r. So now all I have to do is combine like terms. 5r plus 9r is 13r minus 15 over r times r minus 3. That's not 14r. How did I get 13r? Five r plus 9r is 14r. 14r minus 15 over r times r minus 3. And G is our last one. So minus 8x plus 3 over x plus minus 8x plus 2 over 5x. So I'm going to challenge you to pause this and see if you can get it done. We want to find the LCD of x and 5x, and I hope you can see that since x divides 5x, that's going to be 5x. And you might be tempted to factor out the GCF here, because you can, minus 8x plus 2, you can factor out a 2. But in this case, we're going to be adding them in the end, and you don't have to. So let's do minus 8x plus 3 over x. And we're adding minus 8x plus 2 over 5x. Well, my LCD is 5x. So the bottom one doesn't change. And the top one, well, 5x divided by x is 5. So that's 5 times minus 8x plus 3. So there's going to be a little bit of simplifying at the end of this, but it won't be too bad. So remember, you always leave your LCD as is factored. So 5 times minus 8x plus 3 minus 8x plus 2. So this needs simplification. So to simplify it, we have to multiply using distribution. So 5 times minus 8x is minus 40x. 5 times 3 is plus 15. And then I subtract minus 8x plus 2. All of this is going to be over 5x. So now the next obvious step, and it may very well be my last, is to collect like terms. Well, I'm just going to collect them in my head. The like terms are minus 40x and 8x. So minus 40x minus 8x is minus 48x. And 15 plus 2 is 17. All of that over 5x. So the question is 48 a factor of 17? Well, since 17 times 4 is 28, there is a possibility, but I'm not thinking so. Nope, that's 68. So the GCD of those, of the top expression, is just 1. The GCF, GCD, they're the same. So that's it. Minus 48x plus 17 over 5x. And that's it for this lecture.